What's the difference between the electromagnetic waves you encounter with your phone and the ones in radio broadcasting? Both involve an invisible sea shaking, but the way they work and propagate is actually quite different. Let's first take a closer look at the near field, and to better understand it, we'll use the example of wireless charging. Under the wireless charging pad, there's a coil. When you place your phone on the pad, it's like putting two stirring tools on the same small section of the energy sea. These tools tighten and loosen the sea's tension and texture simultaneously. In this small area, the energy sea vibrates back and forth, and energy is exchanged repeatedly between the charging pad and your phone. This energy doesn't travel far. It's much like two people shaking the same blanket back and forth while facing each other. The energy stays confined to the small areas where the shaking is happening, which is why this is a near-field process. It's highly efficient for transferring energy within a small distance, but the energy doesn't travel far. Now let's look at the far field, which is a completely different story. The far field works quite differently, and we can think of it as the light cousins discussed in Season 2. In the far field, the energy sea no longer just tightens and loosens within the same small areas. Instead, the fluctuations in tension and texture are organized into rhythmic wave patterns that propagate outward across the sea in a series of expanding circles. Imagine tapping the surface of water as the ripples spread outward. The energy in the water continues to travel over long distances. This is what happens in the far field. The tension and texture fluctuations move away from the source and continue traveling across the energy sea. These waves are the same in nature to what we call light waves. The only difference is that they vary in their frequency and their specific purposes. At the receiving end, whether it's a distant antenna or a receiving module, it works like another sensory hand inserted into the energy sea. As these rhythmic fluctuations in tension and texture travel from far away, the nearby energy sea is forced to respond to the incoming wave, synchronizing its vibrations in the same rhythm. The receiver then translates these fluctuations back into an electrical signal. Voltage changes or data bits what we perceive as the signal has arrived. In the far field process, the energy is transmitted efficiently across large distances, unlike the near field where the energy is mostly exchanged locally. To summarize, the near field emphasizes the local interaction between the source and the surrounding energy sea. It's perfect for applications like wireless charging and inductive coupling because the energy doesn't need to travel far. It's confined to a small area. In contrast, the far field focuses on the energy sea, helping to propagate the energy across long distances. This is why it's used for broadcasting, communications, satellite signals, and other long-range applications. Once you grasp this distinction, it becomes clear, when designing antennas and communication systems, we're essentially organizing the same energy sea, deciding which parts will stay nearby, vibrating only in place, and which parts need to be shaped into waves that will travel great distances. This concept of organizing the energy sea is fundamental in understanding how electromagnetic waves work and how we can effectively use them to transmit energy and information. The distinction between near field and far field is essential to understanding how devices like wireless chargers, antennas, and even satellites operate. Tap follow, share it on New Physics, Clear Universe.